Okay, so how's everybody doing? So attendance is low today. I hope that doesn't mean everybody else has given up. So basically, for the next few classes, we'll be doing sort of easy or reviewy type stuff. So it's clear from scanning some of the assignment 4 submissions that there were a lot of difficulties. It was clear even before that from the discussions on the forums. And so there's a few things we want to do. We want to revisit objects again because there's more to them than what we've seen, and we also want to go back and maybe look at what we've seen because not everybody has got it. As well, we'd like to play around a little bit with some of the data structures, sets and lists, and see what we can do with those. And so for the next couple of classes, I'll teach you a little bit more about objects, and we'll put together an application that uses objects, sets, dictionaries. It uses a third-party library. It does all of these things. So you'll get a good idea of how all these things work. Now, you guys are the B section of this class. So I'm going to do something unusual, something that I didn't want to do, but just the timing sort of forces this. I'm going to ask you guys to watch the video from Friday's class, the class that's coming this Friday. And the reason that I want to do that is that I know you're not in that class, but it's okay. It's going to be the follow-up to today's lecture. And the reason I want you to do that is because, as hopefully you realize, Monday is a holiday for us. And you guys have a class on a Monday, and so if we just proceed as usual, you guys are going to fall one class behind the other section, which means you'll be one class behind when it comes to reviewing for the midterm exam, which actually would mean that the review would be after the exam, and we don't want that. So find some time this weekend or early next week, and since you don't have class on Monday, I'm going to ask you to watch Friday's lecture on YouTube if you want to see it. And the good thing about that for you guys is that it can save you about 40 minutes or so because you can watch the lecture at double speed. And so you can watch an hour and 20-minute lecture in 40 minutes. Okay. So any questions for me before we begin? Yeah. The midterm is on the 19th, Saturday. Saturday, October 19th, and the time, I believe, is 11:30. It's posted on the web page. And if you are in whatever it is, Cognitive Science 1001. Any of you in that class? Okay, a few of you. So you have a midterm at exactly the same time. Your midterm is later on Saturday. So I've booked a room for us, and I've got a list of all your names, and so it'll be Saturday afternoon, and so I'll give you instructions on that.
My name is Will. I have a question also. Some of us have a business midterm review from 9 to 12.
You have a class on Saturday that's holding a review class?
Yes.
Is it an online class?
Nope, it's in class.
Okay. Who else is in that boat? What's that?
I don't think it's mandatory because I don't think every office doing the review of TA.
Okay. So that's really strange. So I don't know who organized this, but I'll ask you to skip the last half hour of that review. Sorry. That shouldn't happen. Okay. Yep.
And it'll be in our tutorial room then?
No, it'll be in room 2200 of the River Building. The information about, so don't write any of this down because you're liable to make a mistake, of the River Building. It is on the news forum on the course webpage, and I'll post this information again there, which, unless you've unsubscribed, it should email that out to you as well. Okay. Any other questions? So later today, I will post a midterm from last year, so you'll get an idea what it's going to look like. It'll be an hour and a half, but you'll actually have lots of time. So you'll have an hour and a half to do it, but people generally finish in half that time. And the one that from last year was a little short, and so this one will be a bit longer, but still there'll be lots of time to do it. Okay. All right, so back to objects. So we have seen objects, and you've worked with them on an assignment. And so, for example, you've seen, well, what were the kinds of objects you defined on assignment 4? Hopefully you remember that much. Yeah.
Album and track.
Okay, so there were two kinds of objects, album and track. So when we talk about objects, there's sort of these two questions that we ask ourselves. So there's sometimes relationships between objects. And the questions, the two questions, the short version is has a and is a. So for example, a track has a bunch of things. What does a track have? Has a title. What else does it have? Has an artist. Has an album. Anything else? Has whatever, lots of stuff. Has a file name, has a duration, has a, you name it. Okay. And albums, what do they have? Has an artist, has a list of tracks, has a title, and maybe other things. Has a year, has a genre.
Is itself also considered there?
No, just at this stage we're not thinking in terms of programmatically, just in terms of the general concept. So if you think of an album, even outside of programming, an album has an artist and a list of tracks and a title and a year and so on. And track has a title, has an artist, has an album, and so on. And so we've seen when you have this has a relationship, so what that ends up being is that you create in that class, so in the album class, you have a piece of data, and in different languages it's called different things. So that's one of the things about programming language people is they like to make a lot of fancy names, different fancy names for the same things. So in some languages they're called instance variables. In other languages they might be called instance variables, local or object variables, members. There's a bunch of names for them, but they're basically variables that are tied to an instance of that object, right? So, and we saw that basically where this shows up, usually in the first place it shows up is when you write the init method, you take a bunch of arguments that maybe include all of these properties, the artist, track list, maybe title, year, and so on. When you create one of these things, you assign those values. Maybe later you change them, but there's these variables that are associated with each instance of one of these objects. Okay. So nothing deep here. This is all stuff that you've seen before. Now, there's a different kind of relationship that objects can have. Different kinds of objects or different classes of objects, and that's the is-a relationship. So, for example, in fact, the thing we're going to work on today and next class is a system for keeping track of lists of publications. So in such a system, it's sort of easy to come up with some hazard relations, but one of the things that appears in that kind of system is, or one of the objects that naturally pops out is an author. Okay? And another kind of object that naturally pops out is an editor. So books often have editors, and proceedings have editors, and there's authors. Now, both authors and editors are a special kind of something. So what are they a special kind of? So they're very similar, right? If you were thinking about an author, what would an author have? Yeah, has a name. What does an editor have? Has a name. And maybe it's even, you want to be a little more precise, a first name and a last name. It's usually important to split the two if you're going to sort things by authors' names. And the editor has the same thing. Now, author and editor have those things in common. Now, author maybe has some other stuff. For example, maybe an author has a list of publications. So things that they have, a list of, let's say, publications authors. So things that they have written. And an editor has a list of publications that they've edited. So they have some stuff that's the same and some stuff that's different. So the stuff that's the same is their first name and last name. Each of those has that. And then there's this other stuff that's different, that's specific to their role either as an author or an editor. And why is it, intuitively, why is it that they have this stuff that's the same? So what's common between an author and an editor? What is the link? Yeah?
They're both humans?
Yeah. So authors and editors are both humans. So they're both people. And so there's another sort of thing hiding in here, which is this notion of a person. And a person in 95% of the world has a first name and a last name that's distinct. Maybe they have other names too, but they have those things. And now an author doesn't have a person. An author is a person. And because they're a person, they have a first name and they have a last name. And an editor is also a person. And because of that, they have a first name and a last name. Okay? So author and editor somehow both inherit these properties of first name and last name from the fact that they're both persons. Okay? So we often draw this using diagrams, and especially at the early stages when we're just starting to work on a new project. So we make these diagrams that look like this, and in fact, and we often work this way. So for example, we'll say, well, you know, it's obvious that in our application we need authors and we need editors, and then you start writing down what they have, and then you realize there's some stuff that's in common between authors and editors, and even though person is not something that shows up immediately in the application, it just sort of appears because you have these different kinds of persons, and you take the stuff that's common to every person and put it into the person class. So, and in terms of diagrams, usually you end up with some pictures that look like this, where you'll say person, and they'll have first name, last name, and the children, or the things that inherit from person, are author and editor. Okay. And when you inherit this way, it goes without saying that all of the things that a person has, both an author and an editor have. So they'll both get first name and last name. But in addition to that, an author has let's say I don't know, a list of publications authored and a list of publications edited. Okay. So is that clear how we arrived at this? So one of the first things you do when you look at when you're designing an application, if you're doing object-oriented programming, is you write down a big jumble of words like this, all of the things that jump out at you as being objects in your program, and you try and figure out these relationships between these things. So the is-a relationships and the has-a relationships. So what does that look like in code? Well, in Python, it's actually not the prettiest of object-oriented languages, but we'll write it anyway. So we'll have a class called person, and a person in object-oriented terminology is actually descended from an object. So unless there's some obvious thing that's above person, so I don't know, above person in other applications there might be, for example, animal as opposed to vegetable, but for our application, sort of person is the top of the heap, and so it's just a kind of object. Okay, so a person, and that's what this denotes. It says a person inherits directly from an object. Okay, and we saw that typically you have a first name, self, so first name, last name, and you do something like that. Okay? And so that persons aren't completely useless, I'll define a string method for them that converts the person to a string, which you just get by returning the person's first name followed by their last name. Okay? So I think that's the first example that we did almost on day one of this course. Okay. Or the day one of studying objects. So that all seems to work. Now, there's this other class called an author. An author is not directly a kind of object. There's something in between. In fact, an author is a kind of person. That's the closest thing to an author. Just above an author is a person. And now I have some bad news for you. And what I have to show you is an ugly piece of syntax that I wish it was nicer, but it's not. And it looks like this. So when I want to initialize an author, since an author is a person, I'm also initializing a person. And this relationship between author and person in object-oriented terminology is called a superclass subclass relationship. Okay? So there's this kind of objects called persons, and there's these kind of objects called editors, and person is a superclass of editor, and editor is a subclass of person. So that's where this keyword super comes in. And now you use the name of the class that you're currently defining, self, init, and you want to call its init method with first name, last name. Okay. It's a horribly ugly syntax. You will forget it if you stop programming in Python for a little bit, and then you'll look it up. But essentially what this is doing is when I initialize an author, well, first I want to initialize the superclass of author. The superclass of author, here it is person. So I want to call the init method for that class and give it the first name and last name. Let me just check the syntax again. I'm not sure that you need to include self there. Zoop. Yeah, so you don't need to include self as an argument to init. Okay. So basically that calls the init method from this class up here. Okay? Is that sort of clear? And then you say self.works equals works. So these are supposed to be things the author has written. Okay, and now we can say class editor is also a person. And their init method is, they look pretty much the same. So super editor, first name, last name, self.works, things the editor has edited. Okay. So let's test this out. Init takes 4 arguments, 3 given. Oh, I need to provide a list of the works that are edited, right? If I'm creating an author, I'm supposed to provide a first name, a last name, and a list of the edited works. So I'll just give it an empty list. So now me is an author. Okay. And then there's this other me, which is a person. Okay. So I saw that if I print the other me, the person, then what gets called is this string method here, which converts this thing into this person into a string. And so what I see is a nice representation of this person. And that just comes from the fact that that conversion works. Okay. Now, something that happens when one class is a subclass of another is not only do you inherit these variables here, so these variables that get defined in init. So for example, if I look at me, which is an author, me dot has a first name, and me dot has a last name. Me also has some works, which is an empty list. So you inherit the first name and the last name, but you also inherit any of the methods that this superclass supports. So the superclass has a method called string, and so that method also works for the subclasses. Okay, so whether I define an author or an editor, either one of those can be converted into a string using the string method, and what it actually executes is the string method in the person class. Okay. Is that clear? All right. So this actually is a really powerful thing. It's called inheritance, is the whole idea of a subclass inheriting things from the parent class. But the fact that I have both an author and a person that I can convert to a string, in programming language terminology, that's often called polymorphism. So I have these two different kinds of things, so two or more. So poly means more than one. And morphism, or morph, is that these two things have the same shape. In this case, the shape of these things is the shape of a person. So they have a first name, they have a last name, and you can convert them to strings, just like persons. But that person has, these different forms. The person can be an author, it can be an editor. In other applications, there would be other kinds of persons as well. Okay. So we should explore this a little bit more carefully. So, for example, we can define a method, let's say, in the person class called prettyprint, which might, say, do something a little bit different. Maybe it returns something like this. So it does, it's just a different way of printing someone's name, where you put their last name first, followed by a comma, followed by their first name. You see it, for example, if you're sorting alphabetically, you sort by last name so that things get printed this way. And as we expect, so I can say so now I can pretty print an author or an editor, even though this is a method that I've defined in the person class. Now, sometimes editors are really fussy about, they're sometimes you feel that they're really important people, and that they shouldn't necessarily look the same as everyone else. People should know that they're important. So they like to do things like maybe put letters after their name that show how important they are. So for an editor, I could do something like this. I can also define pretty print. So let's so as it stands now, did it again. So as it stands now, I can pretty print an editor, and whether I pretty print an editor, a person, or an author, it's the same result. It just prints their last name followed by their first name. Now, let's say editors feel that they're more important. They should have their own way of being printed. So what you can do is just define a special method just for editors. And let's do that. We'll return same as before, but we'll add that. Okay, so if I say U is editor at Morin, if I do a pretty print of U, u.prettyprint, then it prints differently. On the other hand, if I define a author with the same name, so what happens then? Just prints the name. Okay. So in this hierarchy picture, what I have is up here in person, there's a method called pretty print. And over here in editor, there's a method called pretty print. So when I have an editor and I tell it to pretty print, it calls this method here. That's the one that prints the name followed by the word editor. When I have an author and I call the method pretty print, well, Python or in general the language looks and says, well, author doesn't have a method called pretty print. Is there one defined somewhere else that it inherits from somewhere else? And indeed, if you look at its superclass has a method called pretty print, so that's the one you use. So in general, it tries to use the thing that's most specific, but if that's not defined, then it'll go up to the superclass and look for it. Okay? And actually, there's this goes up even further. For example, I think I can do something like this. So here's a method that I have not defined in any of my classes. And yet, it doesn't give me an error. So from what you know then, there's this method underscore underscore hash underscore underscore that returns a value. So where's that coming from? Yep.
The object class?
Yeah. So remember, all of these, where do we go? There. All of these things are subclasses of object. So person is a subclass of object, author is a subclass of person, and these things are transitive. So when I ask an author to underscore underscore hash itself, it says, well, I don't know how to do that. Maybe as a person I know how to do that. No, it doesn't. It also doesn't know how to do that. There's no underscore underscore hash defined in either of those two classes. So it goes up one more class to object. And so what we've just learned then is that object supports this underscore underscore hash. So that's something that all objects can do. Now, if I don't like the way that hash works, then I can redefine it to work some other way, and I can put that wherever I want. All right. So, any questions so far? Yep.
Is there any way to get an editor to use the pre-print method in the person class?
Is there any way to get an editor to use the pretty print method in the person class? So if we wanted to not have to duplicate that little bit of code, maybe. So there is. I don't know it off the top of my head. I think we can look it up. I think it involves the keyword super again, and I think it's probably just super editor self dot pretty print. Maybe. Let's try that. There you go. So the same way that you, right here, we basically called init from the superclass within init in this class. The same trick works for calling any other method that's defined in the superclass. Now what you wouldn't want to do is something like this. And why wouldn't we want to do that? What's that? Yeah, so if we do that, then basically the way you pretty print an editor is you call self.prettyprint, so then your self is an editor, so you pretty print an editor which calls self.prettyprint on an editor, and you get this infinite recursion if you do that. And we can see what happens, just so if you make that kind of mistake, you'll know what it looks like. Yeah. So you get this, this thing that says maximum recursion depth is exceeded. It prints out the whole list of calls that led up to that error. And of course, that list of calls is a whole bunch of calls to self.prettyprint, because it just keeps calling itself over and over. So this is actually a fairly common thing to do. So, very often a superclass will do almost what you want it to do. So, for example, the superclass person prints itself almost the way we want it to print an editor. So we reuse that by just calling its method, and then we just tack on this, this string editor at the end of the result. Okay. Okay, so questions about that? No? So this is a really advanced concept, right? This is something that people are often confused by, this notion of inheritance and superclasses and subclasses. And the best way to resolve things in your head, if you come across this sort of thing, is to just draw a picture like this. Figure out what the superclasses are, what the subclasses are, and then just remember that, if you have an instance of the author class, so if you have something that's an author and you try and call a method on it, it'll first look for that method defined in the author class, then it'll look for it defined in the person class, and then the object class finally. Yep.
In the textbook, he is kind of advising against that, and it says to use a proposition instead. What's your opinion on that?
I think he has a lot of opinions, strong opinions about things, the authors of the textbook, and I don't agree with all of them. And in fact, one of the main advantages of object-oriented programming is exactly this notion of inheritance. So it's a way of preventing lots of code duplication. So I disagree. Okay. So really, this is clear to everyone? Great. All right. Well, then there's two things we can look at now. One is a technical issue that I want to look at. And at some point, I told you don't put objects into sets or dictionaries or use them as keys in dictionaries because you don't know enough yet. And I'll tell you why that is. So remember we had, if you define underscore underscore EQ underscore underscore, that basically defines what it means for this object to be equal to another one. And a reasonable thing for people, for example, would be if their first names are the same. And their last names are the same. First and first, last and last. There we go. Okay, and now I said, it's fine to do that, but never ever put one of these things into a set. And then we talked about sets and we talked about dictionaries, and I sort of said, well, these sets and these dictionaries are super, super fast, and the reason they're super fast is they give up any notion of order. So unlike lists, they don't store things in a specific order. They store them in some order that's convenient for them. In fact, the way they store things is in an array. And the way they decide where things will go in this array is through this technique called hashing. Okay? So basically, when you store something in a set, the set is really just an array. You take your thing and you hash it. That gives you an integer. We've seen that. So for example, so there's the hash of me. It comes because this hash method is inherited. And this hash method basically tells sets and dictionaries where to put this thing in the array. Okay? So it sort of says, put this thing at array location minus 10,600,000, whatever number this is. Not exactly, it takes this number and converts it into an array index, but that's essentially what it does. Okay? Now, that's fine. So hash, you can think of it as telling sets and dictionaries where to put this thing. Now, if I define what it means for two people to be equal, so that means that if I put those two things into a dictionary, I should put them in the same place. Right? If two people are equal and I put them in a set or I put them in a dictionary, well, they should be put in the same place so that the dictionary can detect that there's two of these things in there. Or if I search for it, it can detect that. And so the short version of the story is, if I want to put these things in sets or dictionaries, all I have to do is define a hash method. And what that hash method has to do is make sure that this thing will get put in the same place as anything else that has the same first name and the same last name. Okay? So, right, or anything else that's equal to this. In this case, equal means you have the same first name and the same last name. So we'll put those two things, we'll want those two things to go in the same place. And there's just a nice way to do that. So you hash self.firstname and self.lastname, that tuple. Okay. So now, if two different people have the same first name and last name, then when I hash one of those people, what I will do is hash their first name and their last name. That'll give me some number. If someone else comes along with the same first name and last name, I repeat exactly the same calculation, I get back the same number. So let's just check that. So if I hash me, and I hash him, I get exactly the same value. Is me equal to him? Yes. Is me is him? There was less confidence there. False, right? Me is a person that was created by this line of code. Him is another object, another person that was created in this line of code. We can sort of see that by inspecting them. It says me is a person object that's stored over here, and him is a person object that's stored over here, and notice those are not the same places. Okay. Now, so I have me, you, and him. So you is this one in the middle here. And we can check, me is not equal to you, but me is equal to him. Hash of me is this value. Hash of you is a different value. And hash of him, of course, is the same as the hash of me because those things are equal. So now, if I put these things in a set, like so, how big is the set? Well, there's different ways to do it. Let's do it this way. How big is this set? 3? 2, right? Because we put me, you, and him in the set, but me is equal to him, and so those two things don't both get to go in the set. Okay. So this would not work correctly if I did not implement this hash method here. And we can try that. We'll either get an error or we'll actually end up with both of them in the set, right? So we don't right. This is what we want, right? We don't want 3 people in this set with 2 of them being equal. Sets are supposed to contain distinct elements, and so we don't want these two people in the set. So for example, if we leave this out and try the same experiment, and this is an error now, so don't do this. This is not behavior you ever want. Okay, so if I turn me, you, him, and her into a set, the length is 4. That's definitely not what we want, right? We want the objects which are equal. They should not both be allowed to go in the same set. Okay. So never do that. If you're going to change the equals method and you want to put things into a set, you should also change this hash method. Okay. So that's the short version of that. The moral of that story is if you override equals and you intend to use sets or dictionaries, then you should also override hash. And in fact, even if you don't intend to use sets or dictionaries, someone else might come along later and want to do that. So it's a good idea just to do it regardless of whether you intend to use them. And in your code, always keep these two things side by side so that someone can check. If they decide to change what it means for two things to be equal, they can also check whether or not they need to change what it means for them to hash. Okay, so that's a really advanced concept. All right. And finally, just so we're all on the same page. So now I've taken this editor class and I've added a new method called print something, which prints something. So okay, so what's going to happen now? Oh. Does anybody see the mistake here? It's one that I make constantly. Self. We forgot the self argument. And this actually tells us, look, it says print something takes no argument, but one was given because we passed a self argument. So let's try that again. So now what will happen? Prints something, as it's supposed to. Okay. Now what's going to happen? What's that? Yeah, so it's going to give an error. So it says person has no attribute, print something. So why is that? Well, we can see it in this picture. So down here in editor, we defined yet another method called print something. And now we defined a person, and right, that's exactly what happened here. We defined a person, and then we asked it to print something. So since this is a person, it starts looking here. It sees there's a pretty print method, there's a last name and a first name, but no method called print something. So it goes up to object looking for a method called print something. There's no method there, and after that there's no other place to look, so it says there's an error. Okay. On the other hand, when we defined an editor and did this, we asked it to print something, it found the method right away down here. So what happens if I ask an author to print something then? Yeah, you'll also get an error, and the reasoning is the same. Author looks for how it can print something. There's no method defined in author. It looks up in its superclass. There's no method defined up there in person. It looks up in another superclass in object, and there's still no method. And then finally, there's no other places to look, so it gives up. Okay? So this looking for methods always starts at this subclass, starts at the class that this object is an instance of, and just works its way up through the hierarchy. It doesn't do anything weird like go across and look at neighbors or things below it. It just works its way up, and it either finds what it's looking for on that path, or it just goes off the top and throws an error. Okay. And we can just check that. And we get an informative message, error message. Author object has no attribute, print something. Okay. So now you understand basically the main material in a course in object-oriented programming. That's it. Yep.
If you were to define a person as first name, last name, can you then convert that person using into the author and editor, just adding the list of works?
No. So if you have a person who is defined as a first name, last name, we have a person like that named you, and you want to make an editor out of that, then you would do something like editor u.firstname, u.lastname, and then the list of works. Okay. And that doesn't convert you. You is still what it was. It's still a person. It just creates a new thing, which is an editor.
If you were to reassign you to something else, would it then change it?
No. So the question is, if I say u is equal to 42, for example, does that affect it? No. Okay. And that's just this box picture here. You had you had it. U was referring to a person, right? And it was referring to an editor. So we created a new editor with the same last name and first name as this person. And so there's actually no link at all between you and it. But even if there were, it doesn't matter, because when we say u equals 42, all we do is cut this link and overwrite, in fact, right in this box, we put 42. So it has no effect at all on this other box. Yep.
I was just wondering, when we hash an object,
Yep.
and then it has other properties, they were hashing based on first name and last name.
Yep.
And say you have like two authors or two editors with the same name but different works. Are you do you eliminate all the other information from the object?
Yes. Yeah. So, I mean, that happens already with equals. So once we say that two people are equal if they have the same first name and last name, that basically says we don't care anything else about any other attributes of those people. They're equal if they have the same first name and last name.
Does it keep one of their attributes? Or does it decide?
What do you mean?
Like, say you had a different set of works, would it keep one once you made them equal?
You mean when you test if they're equal, or when you assign one to the other? So this EQ, this method here, is what executes when I say u equals. So equals equals. So test if they're equal. That's what executes, is that method. You see it throws an error here because it, or rather u, is an integer, so it doesn't. Of course, they're not equal. Well, it throws an error because it's trying to ask for the first name of an integer. But yeah, so this has no effect at all on what happens if I do something like this. That's just an assignment. That just changes what's stored in the box for you in the regular rules for that. Okay. But yeah, so basically by defining equals this way, we're saying two people are equal if their first name and last name are equal. That's the way we treat it, and there's nothing else. It's not a great solution, but for example, up until very recently, in fact, it may still be the case, the entire US no-fly list worked that way. So if you had the same first name and last name as somebody who was a suspected terrorist or criminal, you simply could not get on a plane. So you were, in the eyes of that system, those two people were equal. Your only recourse was to get your name put on another list, which is the list of people who are not, whose name is on the first list but are not terrorists, and there's a big application process that you have to go through to get that done. So there you go. Okay. So let's just copy that into maybe a useful location. So what we're looking at building and what we're interested in building, so this pretty print stuff is just for show. We don't need it anymore. So what we're interested in building is something along the lines of a system like the DBLP. So DBLP is the database on logic programming, which is a bad name for it because it's really a database on all things related to, all publications related to computer science. Now, of course, the internet's not working. So I was going to show you what the DBLP is, but we don't have a working internet connection right now for whatever reason. Anyway, maybe it's easier if I just show you what gets stored in DBLP. We'll go to... So what gets stored in there are a bunch of records that have to do with publications in papers about computer science, books about computer science, and so on. So for example, here's what one of these records looks like. It's an article record, meaning that it's an article in a journal. It has a list of authors. It has a title. It has the name of the journal, the year it was published, the volume it was published in, and the pages it was published in. Here's another one, extremely famous paper in CACM 1961. You'll learn about this in an algorithms class. That's another article. Here's a book, famous book, Donald Knuth's The Art of Computer Programming. And then some other papers. This is one, for example, in a conference proceedings. This is one, another one in a conference proceedings, another article, and so on. So DBLP basically stores tens of thousands or even hundreds of thousands of these records in a way that allows you to search for things and quickly look up, answer questions like, what are all the articles written by a particular author? Or what are all the books edited by a particular editor? What are all the articles or publications with a particular word in the title? So it's basically, it stores everything you'd ever want to know about publications in computer science in a way that makes them easy to search. And now, suppose we want to make our own little version of this system, because it's a big version, it's online. As you see, it's not particularly useful when you don't have internet access. So our goal is to make a mini version of this system that stores not all of the papers ever written about computer science, but the papers that we're interested in, or the ones we have in our database. And I have this directory of these things. With a bunch of these bib files in there. So the goal is to write something that does all that stuff. And now I don't want to have to write code for reading these bib files, so I've used a third-party library called PibTech, and plugged that in to basically the same loop that you guys used in assignment 4, which is it takes a directory name, walks through that directory looking at all the files. If it ever finds one that ends with .bib, it opens it up and tries to load it, and then it uses this third-party library to try and load it. And we'll take a look at what that does. For now, it's not right now, it doesn't do too much. I just added a little bit of code here. So this thing opens this up and loads all those files and stores it in this class called a bib app, which has a couple of things, pubs and errors. So it says it loaded 656 publications. It had 70 errors for various reasons, formatting or whatever. And that's stored in a variable called b now. And the publications themselves, they're stored in an array called pubs. And that's what that looks like. And if we look at these things, they look like this. So actually, these things are just strings. So string is somehow a list of the authors converted to strings, title, the journal name, and so on. Okay? And I'd like to take this information and make it, structure it a little bit. So I want to define objects to hold this kind of information. And so at this early stage, what we want to do is identify the objects and the relationships between the objects. So in an application like this, what are the kinds of objects? We've already teased out a few of them. We think we've got an author, right? And probably there's editors, and we've even sort of figured out a partial hierarchy of classes here. So what other kinds of objects would there be? What's that? Okay, so there's a type. So book or journal or whatever. So let's see. Let's think about that. So that, I mean, book sounds like an object, right? A book is a thing. And you said, well, a journal article is also a thing. Those are what examples we saw. And another thing might be a proceedings article. So an article from a conference proceeding. It's a little bit different than a journal article. And now, interestingly, you said type, like the type of these things, suggesting that they're all from the same category.
Have an e-book or a physical book, that would be what I would describe it. Same thing as a journal would be an online journal or a magazine.
Okay, so you might have, for example, online journal. Well, you might also have a journal. You might have a physical journal. What else? So you've got publication as well. So what are the relationships between these things? So, language. There's another thing that might show up. Okay, so for example, some things we could tease out of this is, for example, well, a journal article. You say it has an author. So is that true? So is that general enough? No. So if you look at the examples we've looked at, here is a journal article. Does it have an author? No, yes. It has more than an author. It actually has two authors. And in general, there can be lots of authors. Here's one with 1, 2, 3, 4, 5 authors. So it doesn't really have an author so much as it has an author list. Which means there's another word to throw in the bag here, author list. So, this is typically what happens when you start one of these projects, is a whole bunch of words come out like this, and now you have to figure out how they're all related to each other. So you know, we figured out one has a relationship, which is that journal articles have an author list. And I guess that's true for some other things too, like books. Probably true for a proceedings article also. So there's some relationships between an author list and and that. Now an author list, I guess we know what that is. Author list has a list of authors. That's good. Now what about some is-a relationships here? Is there anything, any word on this page which is another word on this page? Yeah. Yeah. So books are publications. Journals are publications. So are journal articles. So are proceedings articles. So we're running out of space here. Now, I'll put that over there. Now what about online journal and physical journal? Where do they fit into the picture? They're both journals, right? An online journal is a journal that's online. A physical journal is a journal for which there's a physical copy. So now we're looking at some picture, some class hierarchy that looks like this. Under publication, we have book, we have journal, we have proceedings article, that's supposed to be under, we have journal article, that's supposed to be under, and under journal we have maybe online journal and physical journal. Okay. And then we have this author list thing, which is sort of just a thing all by itself. It's used inside of journal or inside some of these publications. And then we have a language which is also maybe an attribute of some of these things. So journals maybe are in some specific language. So the first thing to do now is to start modeling these things and building these classes. And then we'll see once we've done that, it's pretty quick to fill them up with the information we need. Okay. So that will happen on Fridays, in Friday's class, which I would like you to watch online.